Hello everyone, it's Justin. Like always, I hope everyone's doing okay today. For today's video walkthrough, I'm gonna go ahead and walk you guys through section number 2, practice problems for questions number 3 to 6, which is basically somewhat of chapter 10 components. So, like always, if you have any questions regarding my walkthrough steps or you need any further clarification, feel free to reach out to me through my email or just my office hours. I'll be more than happy to help. So, let's go ahead and get started by answering number 3. So, number 3 is asking us a golf ball is struck by a golf club at a 60-degree angle giving an initial speed of 12 meters per second. So for part A, it's asking us what the golf ball's initial vertical velocity is. So in this case here, what helps me kind of visualize it more is I like to draw things out. So I mean, you can technically draw out the whole person and the whole simulation, but what I like to do, I just like to do a triangle. So what I'm going to do here, since we are given our degree, this one's going to be 60-degree angle here. And then we are giving our initial speed. So remember, when we're talking about our initial speed, it's always going to be that hypotenuse. So right here, it's going to be 12 meters per second. So in this case here, we're just going to be looking for these two here. So our horizontal and vertical. So part A is asking us for the golf ball's initial vertical velocity. So we're going to be looking at this. So when we talk about this, we're going to be looking at SOHCAHTOA. So remember, since we are talking about looking for the vertical velocity, we're in regards to the angle, we know that vertical velocity is going to be the opposite sides. And then we are already given the hypotenuse, so we would just go based off that. Opposite over hypotenuse. We're going to be using sine for this one. So in this case here, we just go ahead and plug it in. So sine of 60 degrees is equal to V of x times 12 meters per second. Like always, you would just go ahead and want to get the vertical velocity by itself. I apologize, it's v of y. So right here, we just go ahead and multiply by each side. So each side, this will cancel out. So in this case, what we would do is we would just get v of y is equal to sine 60 degrees times 12 meters per second. So we just plug that into our calculator, so that would give us a initial vertical velocity of 10.39 meters per second. So that's how you answer part A. Fairly simple. And then you would just go ahead and use the same components for part B. Now in this case, we're just going to be looking for the initial horizontal velocity, so we're more looking for the, this side here. So in this case here, in regards to the angle, um, we're going to be using cosine. So we are looking for the adjacent side, and we're already giving the hypotenuse. So right here, just go ahead and just change the colors. We would just be basically cosine of 60 divided by v of x to 12 meters per second. Same thing. You just go ahead and multiply these by both sides. These will cancel out. So now you just get v of x is equal to cosine 60 divided by 12 meters per second, which would give us an answer of 6.0 meters per second. So that's how you answer part A and part B. Now, for part C, it's asking us how high will the golf ball travel? So just to give myself some space, I'm gonna go ahead and erase these here. So for part C, remember, it's asking us how high will the golf ball travel. So we got to think about what it's asking us here. So how high? We know it's related to the apex, which is the highest point of the projectile motion. So in this case here, when talking about the height of at the apex, we are going to be using one of the vertical cases. So in this case here, we're going to be using equation 2a. If we go ahead and look up, it's going to be this one here. So let's just go ahead and plug this into our equation. So as we know, we're using 2a. It's going to be 0 equals to be 1y squared plus 2 acceleration over distance. So why is it 0? Remember, when we're looking at apex, we know that the very top is going to always be at 0. So we're just going to go ahead and keep it at that. So 0, and we just go ahead and plug this into our equation. So 0 is equal to our vertical velocity, which we knew we got, if I remember correctly, it was 10.39 meters per second squared plus 2. And then remember, when we're talking about acceleration, looking in the vertical component, it's always going to be gravity. So remember, we got to remember the gravity sign. So this is it's going to be negative 9.81 meters per second squared. And then since we are going to be looking for the apex, this is what we're going to be looking for today, which is the distance. So what we would just do here is we would just go ahead and just use order of operations, which is PEMDAS. So let's just go ahead and take care of our, our parentheses first. So 10.39 squared, we just go ahead and plug this into our calculator. That would just give us a value of 107.95 meters squared over second squared. Plus, when we multiply 2 times negative 9.81, we're going to get negative 19.62 squared. And then since we're looking for this, we're just going to go ahead and keep this blank here. So now what we would do here is, remember, the order of operations, we want to get d by itself. So we would just go ahead and try to get 107.95 to the other side. So all we would do here is we would just go ahead and subtract this and add it to the other side now. So when we do that, it would just simply get us a negative 107.95 meters squared over negative 9.62 meters squared times dy. Now, since we're trying to get distance of y by itself, we're just going to go ahead and multiply negative 19.62 to both sides. When we do that, we're going to go ahead and get a distance, a vertical distance of 5.50 meters. And that is our answer for part C. When we're talking about the apex, that is how we find the apex here today. So that is going to be the answer for part C. Now, when looking for part D, let's go ahead and erase this again. This one is asking us more so, how long will the golf ball be in flight? So this one, we're going to go ahead and use those key terms here, how long, so we're going to be looking more so for time. So when looking back at the equations times, we just got to go ahead and, pick and choose where we see time and then obviously what we're going to be looking for here. So in this case, we are going to be using more of the vertical cases, which is going to be 1A, since we are still relating it to the apex flight time. So in this case here, let's go ahead and use the equation. So equation 1A is simply 0. Remember, we always want to keep it at 0. V of y plus acceleration times time. So let's just go ahead and plug this in. So it would just be 0 times, so we got that first, it would be 10.39 meters per second times, or plus, sorry, acceleration, which is the one we're looking at negative at the vertical component. So it's going to be the negative 9.81 times t. So in this case here, fairly simple. We just go ahead and use the same process that we did for the previous equation. So we just get 10.39 on the other side, which will give us a negative 10.39 meters per second is equals to negative 9.81 meters per second squared times time. Since we're trying to find time, we're just trying to get that alone. So what we would do is we would just divide negative 9.81 to both sides. Once we do that, these will cancel out, and that would just give us time is equal to 1.06 seconds. Now, you are not done yet here. So remember, this is relating to the apex. So this is the time it took for the projectile, the golf ball, to reach the apex height. So now, since we know it's going to be in a parabolic trajectory motion, um, it's simple, kind of like a U, think of it. It's basically the halfway point. So since we are given the halfway, we could just go ahead and determine the other half. We would just go ahead and simply multiply this by 2. But remember, this is not 1.06 seconds is not your answer because this is the time it takes to reach the apex height. And then the question is asking us how long will the golf ball be in flight, so the whole duration of it. So in this case here, all we would simply do is multiply this by 2, which will give us a total time of 2.12 seconds. And that would be our final answer for part D. Hopefully that makes relatively sense. Now, when we're talking about part E, this one is asking us how far will the golf ball travel? So when talking about how far, so now in this case, we're not really more so looking in the vertical components, we're more so looking in the horizontal direction or horizontal dimension. So when looking at back at our equations, we're going to be, when we're looking at the special horizontal cases, it's going to be 2h. So in this case here, we just go ahead and plug this into our equation. So 2h is the distance of horizontal distance equals to vertical, horizontal, vertical. Let's see. Since we kind of solved for majority of it, since we're just kind of be basically looking for how far it is, so this would the distance would be blank. We'll leave it blank, but we're already giving the initial horizontal velocity. So in this case, we just go back, refer back to it. It would be 6 meters per second squared times when we already found the time for the previous question. So this would be 2.12 seconds. All we would simply do is multiply this here. So once we do multiply it, that would give us a value of 12.72 meters. And that is equation, the problem for question E. Hopefully all of these made relatively sense. Remember, you just want to find these in order and you should be all good to go. All right, moving forward to question number 4. This one is asking us, uh, a soccer ball is rolling across a field and comes to a stop after 13 seconds. If the ball underwent a constant acceleration of negative 0.6 meters per second squared, what was the ball's initial velocity? So in this case here, we're relating it towards more so the acceleration. So given we have to remember what the formula to find acceleration, I just went ahead and gave me a keynote here. Acceleration is basically the change in velocity over the change in time. So keep it nice and simple. We just plug that into our formula. We just got to read what the what the question is already giving us. So in this case here, we're already given the acceleration, which was negative 0.6, which the keynote it says here, acceleration of negative 0.6. So we can just go ahead and plug that in. So that would give us 0.6 equal, sorry, meters per second squared equals to, so V of 2, remember, we were looking for the change. So V of 2 will have V of 2 minus V of 1. So V of 2, we can kind of defer that it is 0 because the ball came to a stop. So in this case here, we would just gotta put 0 minus. So when we're given the other one, we're trying to find what that value is. So in this case here, we don't know what V of 1 is. but we do know what the time is, which is 13 seconds duration. So in this case, I mean, if you want to just kind of defer how it's going to look like, so you would just simply um, multiply this 13 seconds to both sides. That way you can get the negative v of 1 by itself. So once we do that, these two would cancel out, and then that would just give us negative 0.6 meters squared times 13 seconds. And since we got this, we're trying to look more at the initial velocity, so v1. So once we do that, you know, you just go ahead and multiply these two values together, and that would give us the answer. So v of 1 would be simply, since we're multiplying these two here together, it would give us 7.8 meters per second. So that is the answer for question number 4. Hopefully that made relatively sense. So moving forward for question number 5, is asking us if a figure skater increases their skating velocity from 8 meters per second to 15 meters per second over 4 seconds, what was their acceleration? So in this case here, we're looking for acceleration. So now when we go back to reference our equation, we're just going to keep this blank, but now we're giving more so what the first velocity was, and then the second velocity was as well, and the time as well. So what we just do, looking back at our equation, velocity of the second velocity was going to be 15 meters per second minus the initial velocity, which is 8 meters per second, over the time, which is time span of 4 seconds. So we just go ahead and write this over down here. Now, order of operations, what we would just simply do is we would do A is equal to 15 minus 8. That would give us 7 meters per second over 4 seconds. So once we do have multiple, we would just simply just divide this. So that would give a answer of the acceleration is equivalent to 1.75 meters per second squared. Remember, when you divide, these two become 2, so that's why you have it meters per second squared instead of just meters per second. So that would be the answer for question number 5. You know, relatively simple. Um, these question 4 and 5 is just asking the same equation, but it's just asking for different components. So you just gotta go ahead and find what it is asking. It can also be like, what's the time, blah blah blah, and stuff like that. So just look out for what the keynotes that are given to you for the questions, and you should be all good. Okay. So lastly, for question number 6, it's asking us a juggler tosses a beanbag vertically upward with an initial speed of 3.9 meters per second. How high above the release point will the beanbag travel? So remember, in this case here, where it's basically asking us the height at the apex. So because you remember it's saying how high above the release point will the beanbag travel. So in this case here, we already referred to one of the previous problems. We're just going to go ahead and use equation 2a since we are looking for the height at the apex. So if we just go ahead and plug this into our equation, that would just be 0 equals to, so the vertical velocity that we were given was 3.9, so we just go ahead and plug that in for 9 meters per second squared plus 2, and then remember acceleration, looking at the vertical component is always going to be gravity, so it's going to be negative 9.81 meters per second squared times vertical distance. So same thing, order of operations, we just want to take care of our parentheses. So that would just give us 0 is equal to 3.9 squared. So 3.9 times 3.9, which would give us 15.21 meters per second squared plus 2 times negative 9.81 to give us 19.62 meters per second squared times the vertical distance. So remember, we want to go ahead and get 15.21 on the other side, so we just go ahead and simply subtract it to each other. So once we do that, these two will cancel out, and then let me just go ahead and move down here, but it's just going to be still the same question. 15.21 equals to negative 19.62 meters per second squared times vertical distance. So now we're trying to find the apex height, so we just simply try to get what we're given by itself. So this is what we just go ahead and divide both sides. Once we do that, these two will cancel out. So that would just give us apex height is equivalent to 0.78 meters. And that is the answer for question number 6. These questions are relatively, just follow them in order and you should be okay knowing which equations to use for what you're trying to find, and you should be okay to go. Remember, if you have any questions regarding my walkthrough steps or processes, feel free to email me or let me know. And during lab times, I can go ahead and help you and clarify things. So, yeah, hope you guys have a good one and take care.